Hello class, happy Friday. Today we're going to finish our lesson on two-step inequalities, so let's see if we can review what it is that we need to do. Well, the first question I have for you today is, would two-step inequalities be worked the same way as two-step equations? Well, if you listened to the lesson the other day, we found out that solving inequalities, or finding the solution set to inequalities, is exactly the same as finding solutions to equations. So yes, we do solve two-step inequalities the same way. There's only one catch, and we'll talk about that in just a minute. So the first thing that we have to do in any equation is we've got to get rid of our add subtract. Okay? And the way we do that is we add the opposite. Because what we do whenever we're solving equations or inequalities is the same way that we would solve an order of operations problem. In order of operations, you work everything from top down. You start with your parentheses, you get rid of those first, then you get rid of exponents, then you get rid of multiply, divide, add, subtract. And when you're done with that, you end up with an answer. Well, in an equation or an inequality, you already have an answer. So we have to work backwards to find out the missing part. So we start off by getting rid of the addition and subtraction by adding the opposite. Then we get rid of multiply, divide, because that's the next rung on the order of operations chart. We get rid of multiply, divide by doing the opposite. But what we need to remember in an inequality, if the coefficient or the number that's with the letter is negative, you have to flip the inequality when you get to that part. Okay, so let's see if we can dive into this and answer a few questions. So let's first review an equation. Okay, now the date up there is a little different because, no, it's not actually, it's just fine, never mind. So let's see if we can solve these two warm-up questions real fast to get our mind going. Okay, so in this first one here we have an equation. Okay, so an equation, we start off the way I've taught you. Anytime you see a subtraction, you change subtraction to addition next to its opposite. And now we have to get rid of the plus and minus. That means I got to get rid of this 4. And we do that by adding its opposite. So we do 4 plus negative 4 plus negative 5m is equal to negative 17 plus, and then the thing that I added on the other side, which is negative 4. Okay? So we add that to both sides. So we end up with, on the left-hand side, when I simplify this line, is negative 5m is equal to negative 21. Right? So now I got to get rid of the multiply. And we get rid of multiply by negative 5 by doing a divide by negative 5. Okay? So I divide both sides by negative 5, and I end up with m is equal to, and now I'm put this answer here to check to see whether or not you were paying attention yesterday. You know, yesterday I told you that in algebra, an improper fraction is just fine as long as the improper fraction is simplified. And simplified means that your numerator and your denominator only have a 1 as a common factor. So we look at 21 and 5, and they do only have a 1 as a common factor. But they're both negative, so that makes our answer positive 21 over 5. Now that's one of the 3 answers that I would accept on this particular problem. The other one, if you actually do what you've been doing, ever since you worked fractions, you could simplify or you could change this improper fraction into a mixed number. So we ask ourselves, how many times does 5 go into 21? 4 times, with 1 left over. So you could have 4 1/5. Or if you type 21 over 5 into the calculator, you end up with 4.2 as an answer. And any one of those 3 answers will be acceptable in this particular problem. So now let's look at what it is that we're doing today, which is solving two-step inequalities. Now the nice thing is you solve these exactly the same way you solved equations. So the first thing I get rid of is the 7. Okay, so we do negative 3x plus 7 plus negative 7 is greater than 13 plus negative 7. So we simplify this side and we end up with negative 3x is greater than, and then 13 plus negative 7 gives us 6. Okay? So now we have to divide by negative 3. Okay, to get rid of this 3 right here, we divide by negative 3. So here's where we got to pay attention. Okay, so it says in our rule back here, it says do the opposite. If you have a negative coefficient, flip the inequality. So in this one right here, we do have a negative coefficient. So when I'm solving this part, if I multiply through or divide through by a negative, this inequality is going to flip when I do this step. Okay, so I simplify these, they become 1. So I end up with x And then instead of being greater than, it actually flips to a less than. And then we've got 6 divided by -3, which gives us -2. So to do a quick graph on this, we put a -2 on our graph. And since it's just a less than symbol, that will be an open circle. And I need values that are left of -2 or less than -2. So if I picked a value inside this solution set, say -3, okay, because that would be part of this solution set, I could come back and plug it into this inequality. -3 times -3 plus 7, is that greater than 13? Well, -3 and -3 make 9, so 9 plus 7 actually gives us 16. Is 16 greater than 13? And yes, it is, so that means that this answer works. And that's what we're working on today, is just solving two-step inequalities. So let's just do a simple one, okay? So this one right here, we'll start off by getting rid of the 5. So we do 2x plus 5 plus -5 is greater than 7 plus -5. And that step is exactly the same as what we've been doing in equations. So our 5's go away and we're left with 2x is greater than, and then 7 plus -5 gives us +2. So here is where we look for our coefficient. Is our coefficient negative? No, it is not. So we do not flip the inequality. So we divide by 2, x is greater than 1. So we come over here to do a quick graph. We put a hash mark on the line there. We put a 1 underneath it. This kind of an inequality makes us have an open circle, shade to the right, because all values greater than 1 will make this a true statement. Let's try a couple more and then we'll call it a day. Okay, so here's the next one that we have. Now there's a couple things that are interesting about this one. Okay, one, you probably feel uncomfortable because this stuff is on the right-hand side of the inequality. Well, if you want to, you can flip that. Okay, you just have to be very, very careful when you're dealing with an inequality. Okay, so if you're going to flip it, you take this, you write it down. Take the -22, write it down, then do the inequality. And the part that you have to be careful with is you've got to pay attention to which side is the alligator in elementary school eating. Okay, it is eating the 3x plus 5, so you need to make sure that when you rewrite it, it's still turned the same direction, eating the right thing. Okay, so now we solve. We solve by getting rid of the 5. So 3x plus 5 plus -5 is greater than or equal to -22 plus -5. Okay, same thing. So the 5's go away. We're left with 3x is greater than or equal to. We add these two together. And again, if you're having trouble with these integers, please make sure you type it into your calculator. You get -27. You divide both sides by 3. You get x is greater than or equal to -9. So this time, if you were to graph this one, you come put your -9. But because it's a greater than or equal to, that means it's a closed circle, not an open circle this time, because we include -9. And then we shade to the right. Okay, let's do 2 more, and then we'll be done. Okay, so in this one, we've got -8x minus 12 is less than 12. Okay, so if we have a minus, what I've taught is change subtraction to addition, next number to its opposite, then begin working the problem. So we get rid of this -12 first. So -8x plus -12, and to get rid of it, we add a +12. Is less than 12 plus, well, the new 12 that I added on that side, we add it to the other side as well. So we got to remember that we have to add the new thing to both sides. So the 12's go away and we're left with -8x is less than, and then 12 and 12 make 24. Okay, so here's where we have to check. Is our coefficient negative? Yes, it is. So whenever we work this step, this inequality is going to flip from less than to greater than. So I divide by -8, divide by -8. So x is not less than, but greater than -3 when we do our division. Okay, so that tells me that any value greater than -3 will make that a true statement at the top. Okay, so we come over here, we put in -3. It's going to be an open circle because we don't include it, and I shade to the right. And if you're not quite sure, check it and find out. Okay, when we look at this, we've got -2, -1, 0. So those are some values that are part of the solution set. So I'm going to use 0 to check this with, because anytime I can use 0, it's easy to do. Okay, so negative 8 times 0 minus 12, is that less than 12? Well, negative 8 times 0 is 0, so we end up with a negative 12. Is negative 12 less than positive 12? And yes, it is. So it works. All right, let's try one more, and then we'll be done for the day. Okay, so what if I have a division problem? Do we do it any different? No, we don't. We start off by getting rid of the positive 5. So x over 3, and remember this could also be written as 1/3 x. It's the same thing. Okay, so plus 5 plus negative 5 is less than or equal to 9 plus negative 5. So x over 3 is less than or equal to 0. Oh, excuse me, no, that should be a 5 there, not a 9. What am I thinking? Okay, this should be a negative 5. Okay, so that actually gives us a positive 4 here. I'm so sorry about that. I don't know what I was thinking there. Okay, so now, how do I get rid of this divide by 3? We do a multiply by 3. Or how would I get rid of this multiply by 1/3? You do a multiply by its reciprocal, which is also 3. All right? So if I multiply this side by 3, I multiply this side by 3. And we look, is this coefficient, this number with our variable, is it negative? No, it's not. So our inequality does not flip. And we end up with x is less than or equal to 12. So we come over here to do a quick graph. We put a 12. Because it's less than or equal to, we do a closed circle and we shade to the left. Okay? So to solve inequalities, what you have to remember is, okay, you solve them exactly the same way we do equations. But if our coefficient is negative, okay, and you can tell that right off the bat in the equation, if your coefficient is negative, you're going to end up flipping your inequality in your answer. And that's how you solve two-step inequalities.